Hey everyone, in the last session we saw how to write the functor applicative and monad instance for the state type. Now we will take a look at its transformer variant, StateT, and how to write the functor applicative and monad instance. So let's start by writing the StateT type. It will have SA just like the state, but it will have an extra layer which would be of a monad structure. It can be a list, maybe anything. We will have an unwrapper function, let's call it run state t, that will take s and it will return us a tuple a comma s, but this tuple would be inside a monad. So let's start by writing the functor instance. Now we need to specify here that this m here is has the monad instance. So I would say monad m. Now let's start with fmap. So fmap takes a function that will convert type A to type B, and we will take a value of type A that is within the context, which is state tsm of type A, and we would basically extract out our A value, provide it to this function, we will get B, and we will put this B into the state context. So it will be state tsm. Let's start fmap, the function, let's call it f, and we will destruct state t, and we will have SMA. Now this SMA has the type s, a function that takes s and it returns the tuple a comma s within the monadic context. Now since we have this m that has the monad context, we can use the do notation. We can use the bind operator as well, but the do notation is much easier. So SMA, I am going to provide it s. This will give us the tuple in the monadic context. I'm going to call it MAS dash. Now MAS dash, we can simply extract the tuple out of it using arrow. Now all we have to do is simply apply our A to function f, and we are supposed to return it as a tuple with the latest state, that is s dash. We must put state somewhere, it should be state t. Okay, so we cannot just simply return this tuple, we need to return this tuple in the monadic context, so we can use return, and it worked. Now let's write the applicative instance. Again, we need to specify that m is as the monad instance. Now applicative has two operations. First is pivot, that takes the value of A type and puts it inside the context, which is state t. So let's say our value is x. So all we have to do is state t as we will return the tuple x with the state s, and obviously we cannot just simply return the tuple, we need to return this tuple within the monad context, so we use return. Great. Now let's have our applicative operation, which is basically that is similar to fmap, but this in this operation our function will also be inside the context. So it will be state t sm will be the function that converts A to D. We will have our A value within the context, state sm A, and it will convert it into the type state tsm. Now let's say state tsmf for the function, and we'll have state tsma. Again, we can use the do notation. So what we can do, smf will provide rs, and it will give us the tuple within the monad. So I'm going to call it smf s dash. Now we can extract our tuple using arrow. This will be f and this new state s dash, and now we have to do same for our SMA. So I will provide it the latest state, that is s dash, and it is going to give us the tuple within the context. So mas dash dash. Now we can extract mas dash dash. This will give us the tuple with a s dash dash, which is the new state. Now all we have to do is apply af. This will give us the value b and the latest possible state, that is s dash dash. We are going to return this tuple, and we need to return it within the context. So return. That's it. Now finally we'll have our monad instance. So return will behave the same as viewer, and we have bind operator that takes the state within the context as in a, and it takes a function that takes a and returns the value b, but b would be within the context, and we need to return that b within the context. So let's do it. State t sma, and I will call it f, the function. Now state t $s 2. Now same as before, SMA we provided the s. This is going to give us the tuple in the context, in the monad context. Then we can extract it using arrow as, and we can apply our a to the f. This is going to give us the state, right? It is giving us the state, but we want p comma s within the monadic context. So in order to extract this function, you can use our for unwrapped function, that is run state t. So let's see. Okay, it is waiting for the s, so we can provide it the latest state, that is s dash, and it. So yeah, these are all the monad applicative functor instance for state transformer variant. I will have this code in the description. Thank you.